Hi, so this is going to be the video for Objective 4, which is factoring perfect squares. So this is the third method of factoring that we're going to look at. The first was greatest common factor. Remember, that's the method that you try to do on every single question, no matter what. That's your first attempt when you're factoring. The second method we looked at was when you have a difference of squares and how to factor that. And this one is going to be how do you factor a perfect square. So we're going to flip over to our flow chart to start. And so we started our flowchart with the expression that you're being asked to factor. Your first attempt at factoring is going to be to remove that greatest common factor, and we had an example here. The second method of factoring we looked at is what do you do if you have a difference of squares? So that's two terms, a minus sign in the middle, and both terms being perfect squares. We didn't add in an example there, so let's add in a quick one of x squared minus 9. So two terms, a minus sign in the middle, both of those are squares. So we'll add two sets of brackets, square root from that first term, which is x, square root from the second term, which is the 3. One of the brackets gets a positive and one of the brackets gets a negative. Okay, so what if what we have is not a difference of squares? What if it looks different? What if it doesn't have two terms or all the other criteria? Potentially, what you may have is a perfect square. And so just like difference of squares, there are three identifying characteristics of a perfect square. The first is it has three terms. The first term and the third term are perfect squares. And then this is the kicker, the second, or this third criteria, the second term is equal to 2 times the square root of the first term times the square root of the third term. And this is the last feature that you have to verify before you can kind of go ahead and factor it as a perfect square. This is the last thing you need to verify. The first two things are easy. You can just tell them by looking at them, right? How many terms does it have? Just count them. Are the first and the third perfect squares? Just look at them and sort of investigate. This you sort of have to calculate. It doesn't take very long. I know it looks a little confusing now, but once we get into it, you're going to see it's not that bad. So those are the three things we're looking for in order to identify it as a perfect square. Once you identify it as a perfect square, it's pretty straightforward factoring. So let's get to some examples. Okay, so let's have a look here. So we have x squared plus 20x plus 100. Is there a common factor? That is the first question you need to ask yourself every single time of factoring. Is there a common factor? And the answer is no. This has no numerical coefficient. This has no variable. Therefore, there's not going to be anything in common because it has to be common to all three. So if there's nothing in common to the first and the third, there's nothing going to be common to all three of them. So once you kind of throw out, it doesn't have a common factor, then you go ahead and you're into that bottom of your flow chart. Is it a difference of squares? Well, no, it has three terms, so we already know for sure it's not a difference of squares. So that leaves us with, today, one other option, which is perfect squares. So does it fit the criteria to be a perfect square? Does it have three terms? 1, 2, 3. Check. Are the first and the third terms perfect squares? Yes, that's a perfect square. Yes, that's a perfect square. So the last thing we need to do is double check this middle term. So is that middle term 2 times the square root of the first times the square root of the third? Okay, well, 2. What's the square root of the first? Square root of the first is x, so we're going to multiply 2 by x. What's the square root of the third? That's 10. So is that middle term 2 times x times 10? That gives me 20x. Is 20x the middle term? Yes, it is. So we have a perfect square. This is a perfect square, and that's the last sort of thing you need to check off your list. So once you know that it's a perfect square, the factoring is really easy. You make a single set of brackets and you square it. So that set of brackets is squared. Then you take the square root of the first term, and that goes in your bracket as your first term. You take the square root of the third term, that goes in your bracket as your second term. And then you take the symbol from the middle term, and that becomes the symbol inside your set of brackets, and that's it. So if you want to kind of think backwards about why this is the way it is, think about if in the fall I had given you a question of x plus 10 squared and asked you to expand. So you would have set 2 sets of brackets and went ahead to FOIL this. So first, x squared. Outer, 10x. Inner, 10x. Last, 100. And then we would have combined these two terms to give us x squared plus 20x plus 100, which is what we started with. So that's why this factoring works. All right, let's do some more examples. Okay, x squared minus 8x plus 16. Greatest common factor. No number, no letter, no common factor. Is it a difference of squares? Well, no, it has 3 terms, so clearly that's out. Is it a perfect square? 1, 2, 3 terms, check. Square, square, check. Is this 2 times the square root of the first, which is x, times the square root of the third, which is 4. 2 times x times 4 gives me 8x. That is the middle term. The negative or the positive doesn't matter. It's just whether that's the value of the middle term, and it is. Therefore, we're go for perfect square. It is a perfect square. Single set of brackets squared, square root the first, square root the third, symbol from the middle, and we're done. Let's look at another one. 16x squared plus 24x plus 9. Greatest common factor. I know that the only factors of 9 are 1, 3, and 9. None of those other than 1 is a factor of 16. Therefore, there's not going to be anything in common to all 3 of those terms. So I know there's no common factor, so then I jump into the bottom of my flowchart. What kind of question do I have? It's not a difference of squares because I have 3 terms. Is it a perfect square? 1, 2, 3 terms, check. Is that a square? Yep. Is that a square? Yep. So that's another check. Now we need to check this middle term. 2 times square root of the first is 4x, square root of the third is 3. 2 times 4x gives me 8x, times 3 gives me 24x. So that is the middle term, so this is a perfect square. Single set of brackets, square that single set of brackets. Square root from here, 4x. Square root that, 3. Symbol from the middle, plus, and we're done. So if you can identify the perfect square, the factoring itself is quite straightforward. The hardest part about this is identifying the middle term, making sure that that middle term is what it's supposed to be. If you can do that, the factoring itself is not that difficult. Next question. Getting ahead of myself. Do we have a common factor? 25, the factors of 25 are only 1, 5, and 25. None of those other than 1 are a factor of 4, so nothing. Is it a difference of squares? No, we have 3 terms, therefore it is not a difference of squares. Is it a perfect square? Well, let's see. 1, 2, 3 terms, check. That's a perfect square. That's a perfect square. Is this 2 times, what's the square root of the first one? 2x. What's the square root of the third one? 5. 2 times 2x gives me 4x, times 5 gives me 20x. Is that the middle term? Yes, it is. So this is a perfect square. Single set of brackets, squared. Square root that, 2x. Square root this, 5. Symbol from the middle, minus, and we're done. Next one, 3x minus 18x plus 27. Do we have a greatest common factor? And on this one we do, because I see right away that 3 is a factor of 18 and 3 is also a factor of 27. So on this one I'm going to take out 3 as a common factor first. So then what remains from this term is the x squared. What remains in the middle is 6x. What remains in the last term is a 9. 3 times x squared gives me the 3x squared. 3 times negative 6x gives me negative 18x. 3 times 9 gives me 27. So then once I've taken out a common factor, now I need to look at what's left inside the brackets and see if I can keep factoring. Is that a difference of squares or a perfect square, which is all we know how to do up to now. But is it either of those things? It's not a difference of squares because it has 3 terms. Is it a perfect square? 1, 2, 3 terms. Square, yep. Square, yep. Now we have to check that middle term. 2 times the square root of x squared is x. The square root of 9 is 3. 2 times x times 3 is 6x. That is the middle term, therefore this is a perfect square, therefore I can keep factoring this. So my common factor is going to stick around. One set of brackets squared, square root this, square root that, symbol from the middle, and I'm done. Last question we're going to look at here. Do I have a greatest common factor? This first term is negative. So at the very least, I'm taking out a negative as a common factor. But can I take out more? And if I look, I've got an 8, an 8, and a 2. 2 is clearly a common factor of 8. So we can take out a negative 2 as a greatest common factor. There's no variable component because this doesn't have a variable. So I'm not going to take out an x in addition to the negative 2. So what remains then is going to be x squared, negative times negative to give me the positive, 2 times 4 to give me the 8x, and then negative 2 times positive 4 to give me that 8. Then I look at what's left inside the brackets. Is this factorable? Is this a perfect square for today? And the answer is yes. 1, 2, 3 terms, that's a square. That's a square. Let's double check the middle. 2 times the square root of the first is x. The square root of the third is 2. 2 times x times 2 gives me 4x. That's the middle term. This is a perfect square. My greatest common factor is going to hang around. Single set of brackets squared. Square root that. Square root that. Symbol from the middle. There's my final answer. All right, so let's head back over to factoring perfect squares on our flow chart for a minute, and we're going to fill in one more example here, just to kind of fill out our flow chart. We forgot to do that in last day's video. So let's put in x squared plus 22x plus 121. Okay, so 1, 2, 3 terms. Square, yes. Check that middle term. 2 times x times 11, which is the square root of 121. 2 times x times 11, 22x. That's the middle term. This is a perfect square. Single set of brackets squared. Square root this. Square root that. Symbol from the middle. And we have ourselves a factored question. All right, that about does it.